Hello everyone, welcome to the fifth lecture of P block elements. And in this lecture, we will be covering the group 17 of the P block elements, and we will cover the entire NCERT portion of what is relevant to your syllabus. And keep in mind, a lot of people ask me that this is not for the JEE Advanced. Because, like, see, in JEE Advanced, you have to master the compounds portion of P block elements, which is not there in JEE Mains or NEET. So, if you are preparing for JEE Mains or NEET and you have never touched P block before, or just want a brush up of concepts on the NCERT level, this series is a good go for you. And if you have any doubts, you can PM me on Reddit or ask in the comment section. And that is enough yapping. Let's begin. Group 17 elements. What are the group 17 elements? The group 17 elements are fluorine, chlorine, bromine, iodine, and astatine. Now, one thing I want you to know is that astatine is a radioactive element, and its chemistry hasn't exactly been established yet because astatine is one of the rarest naturally occurring chemical substances on Earth, to the point that only 30% of it exists. What am I saying? Only 30 grams of it exists in the entire Earth. Also, I will be using this temporary pen to write down the facts which aren't necessary for you to remember. So that is a new addition to our series, and it's cool. I can use multiple colors. Like, it's funny. This neon laser thing, and I can also use it to explain like fluorine has A, chlorine has O. Yeah. So one thing special about the group 17 elements is that unlike any other group, these elements show a lot of similarity with each other, which means that they have very identical properties. Like even in organic chemistry, when you study about halides, you see that they have similar properties like Cl2 it adds to double bond, Br2 adds to double bond. I mean, and even fluorine does have a tendency to add to the double bond. There must be reasons why it's not as prevalent as both of these, and iodine does as well. So basically, all of them have very similar properties to each other. And astatine is just basically we haven't established its chemistry yet, so we aren't going to talk much about astatine. But other than that, let's begin our journey of P block elements. So, fluorine and chlorine they are very abundant, but the iodine is less abundant. So let's talk about occurrence first. Occurrence or abundance. Like this is, we always begin our lecture. So basically, if we talk about fluorine first, remember in last lecture I told you that how PBS galena it is a ore for both lead and sulfur. So similarly in group 13 we studied about Na3Al F6, which is cryolite. Now in group 13 we studied this as an ore for aluminium, but it is also an ore for fluorine now that we are studying group 17 elements. So I want you to remember this again. I will make you remember a lot of stuff. And another ore for fluorine is basically CAF2 or CAF2. That's the chemical formula, and we call this fluorspar. Fluorspar. I like that name. It sounds like some kind of Renaissance thing, but yeah. So CAF2 is called fluorspar, and Na3Al F6 is called cryolite. And there is one more ore which the NCERT mentions, which is 3Ca3 phosphate ion whole twice dot CAF2. Like what is this? This is some kind of like attachment to CAF2, but I don't know. But the NCERT calls it fluoroapatite. Fluoroapatite. Like how do I remember this? Well, think of it like this is some big fat ugly dude which is eating the fluorine. So it has an appetite for fluorine. So fluoroappetite. I know this is a really bad joke, but it sounds like a bad joke at first. But if you remember this as a bad joke, you are going to remember what fluoroappetite means. some big fat ugly dude which eats fluorine. So that was it for the ores of fluorine, I guess. Yeah. So that's it. The NCERT does not mention much stuff about this. And what else do I have to say here? That they have configuration NS2 NP5. And yeah, now let's talk about the most important part, the trends. In every P block lecture, the trends is the most important part, and also the chemical properties, but trends is more important. So, first, let's talk about the atomic radii. How does the radii of group 17 vary? Now, if we happen to exclude the noble gases, the group 17 elements have smallest radii in their period. What does this mean? You know, you have studied in periodic properties how the atomic radii it decreases as we go from left to right. So this is just a mere consequence of that, and they have the smallest radii in the entire period. For example, that oxygen is bigger than fluorine, and say sulfur is bigger than chlorine. So it is just because of this trend that group 17 elements have the lowest radii in their periods. And if we talk about within the group itself, then of course atomic radius it increases top to bottom. Like this is one of the most basic things you have to know. And if you're having trouble grasping this concept, then I think you should focus on physics and mathematics because it's too late for I won't say much. And that is it. There is no exception to this in the group 17 elements. And if we now talk about the ionization enthalpy, what is the ionization enthalpy? The ionization enthalpy is basically if I have a nucleus over here and this is an atom. So the in order to take away an electron from this nucleus, I will have to provide energy to take this guy out. So that energy which I need to provide to take this guy out is the ionization enthalpy. And as you can tell, the further the electron is from the nucleus, it is easier for you to remove that electron. So as a direct consequence of the trend of atomic radii, we can say that the ionization enthalpy it decreases as we go top to bottom because it's very simple to understand. In fluorine, the this is very electron is very close to the nucleus, so it's very hard to take it out because the nucleus has a very pronounced effect on the electron. But in iodine, the nucleus just doesn't care. It has so many electrons that it can hardly mind the outermost one going away. Like it's okay, it's got its own inner core and it's happy with that. So that is why the ionization enthalpy decreases as we go from fluorine to iodine. Now, just for your reference, I'm just going to write the order of the group 17 elements here. Like this is not a trend, this is the order. Like if you go from top to bottom, what does it mean? It means you go from fluorine to chlorine to bromine to iodine, and we are not considering astatine over here. Okay, yeah. So one second. And one more point, the NCERT says that they have very high ionization enthalpy. And in fact, I'll write this in actual ink that their ionization enthalpy is highest in period. If we exclude the noble gases, of course, we who talks about noble gases, they are just very nonchalant and shit. We don't need to consider them in our this lecture. Their next lecture is going to be all about them, like the last lecture of the P block series. And I think that is it about the ionization enthalpy. So now let's talk about the electron gain enthalpy. What is the electron gain enthalpy? It is basically the magnitude of energy which is released or absorbed whenever I have to add an extra electron to this atom. So that is the electron gain enthalpy. And the NCERT says that the group 17 elements again have the highest electron gain enthalpy in their periods. Yeah. So now let's talk about the within the group itself. So this is one of the only trends of the group 17 elements which show an exception to a normal straight order. So the what is this exception? That if I look at fluorine, chlorine, bromine and iodine, so the value for fluorine is, you can apply the units yourself. It is negative 333. For chlorine, it is negative 349. For bromine, it is negative 325. And for iodine, it's negative 296. Which means that if I look at just the magnitude, then the actual order becomes that chlorine has the highest magnitude or the most negative electron gain enthalpy out of the entire group 17 elements, and it is followed by fluorine, then bromine, and then iodine. Like if you were expecting a normal straight order, then chlorine would be here, but this is the actual order for the electron gain enthalpy values, and you have to remember this because it is very important and it can be asked directly or indirectly in a lot of chemistry questions. Understood? And one second again. Now, if you want to understand the concept of electron gain enthalpy and why is it so high for halogens in a more intuitive way, think of it like this. They have this electron configuration which is basically anything, and ns2 np5. So you know that a noble gas configuration which is ns2 np6, that is very stable. So if you give this one more electron, this becomes an ns2 np6 configuration. So it is going from a less stable state to a more stable state. So if this, if you are going from a less stable state to a more stable state, of course energy will be released because stability is more when the energy is less. So in order to reach that stable state, it is giving away more energy. And this also shows that the process is like kind of spontaneous because it would love to get the noble gas configuration and it doesn't mind losing a bit of energy in that process. Now, why is this exception there? Like why is the electron gain enthalpy of fluorine smaller than that of chlorine? Why isn't there a smooth trend? This is because fluorine shows anomalous behavior again due to lack of d orbitals and its small size. So this small size primarily causes its electron gain enthalpy to be less than that of chlorine because the nucleus plays a major part, and if the nucleus is so close to the outermost shell, that just causes complications and hence it falls back behind chlorine. There are strong inter-electronic repulsions in the small 2p orbitals of fluorine. This is a line in the NCERT, like I have opened the NCERT right beside me so I don't miss any point. Basically, fluorine's small, I'll just write the reason, because fluorine's 2p orbitals show strong inter-electronic repulsion. Also, props to the guy who told me to keep the NCERT in front of me so I don't miss any point. That's a great suggestion. And till now, I was like relying only on my memory and my teaching notes, but I hope I haven't missed any points in the earlier lectures. I have not. Don't worry. Yeah. So this was it about electron gain enthalpy. And if we just talk about the electronegativity, the electronegativity follows a simple trend that fluorine is the most electronegative element, followed by chlorine, like in group 17, varna otherwise it is followed by oxygen and nitrogen, and it decreases down the group very smoothly. And I think one point you should know that the electronegativity of chlorine is almost same as that of nitrogen, and this won't be asked to you, but I just want you to remember it as a fact. Like the order is fluorine is greater than oxygen greater than nitrogen, which is equivalent to chlorine. Yeah, so that was it about the trends of periodic table group 17. And now let's talk about the physical properties. Now this is one of the rare groups in which physical properties actually matter. because there are a lot of trends mentioned in the NCERT. Like they give that table in every group, but here it is mentioned as separate points, so we have to pay a lot of attention to that. Now, first of all, a good news is that group 17 elements show smooth variations, like the boiling point and the melting point. They steadily increase with atomic number. For example, that this what does this mean physically? That the melting point of iodine will be greater than bromine, will be greater than chlorine, will be greater than fluorine for both melting point and the boiling point. So that is great news for us because we now don't have to consider any weird exceptions. And the same smoothness can be observed in the density. The density of group 17 elements increases as we go from top to bottom, which is same as saying with increasing atomic number. Like iodine is almost 5 on the unit where bromine is 3.2, chlorine is 1.6 and fluorine is 1.5. So density increases top to bottom. But one striking exception, which is very important for you to remember, is like I'll even write it in red colors. Let me pick a good shade of red. This looks good. That the bond dissociation energy, it follows a weird order. Like normally you would expect that fluorine is a very small atom, so it will form a strong bond. So the expected order would be that fluorine has stronger bond dissociation energy than chlorine, greater than bromine, greater than iodine. But actually, this is not the case. The bond dissociation enthalpy is highest for chlorine. And why is that? This is because that if you look at the fluorine diatomic molecule, its small size causes these lone pairs to repel each other, which causes this bond to weaken a bit. So it becomes easier to break this bond. So which that is why this fluorine just comes right behind iodine and the bond dissociation energy becomes an exceptional one. And notice how it jumped not only chlorine but also bromine. So, and in fact, if you look at the data, fluorine is all very barely stronger than an iodine bond. Iodine bond. Like this is 158 kilojoule per mole, and this is no. What am I saying? Fluorine is 158 and iodine is 151. Right. So that's it for the physical properties, I guess. Let me see if there's any other points. Well, I don't know if this is important or whether they have asked questions from this separately. But I'll just mention this point because perhaps they can ask this in salt analysis or something. That this is a very interesting property which we haven't seen before, that group 17 elements show colors by absorbing radiation. Like basically think of it like Hulk. They just they inhale some weird shit and then they start glowing. Like yeah, Hulk was bit. I don't remember the entire story. It's been years since I've watched any movies, but basically what I want you to do is remember the colors. They are not hard to remember compared to the type of colors you have to remember in other chapters. Basically, I'll even write it with the color scheme. Fluorine is yellow, chlorine is greenish yellow. Shit, that looks like this. 1 second. Chlorine is like greenish yellow. Is that even greenish? Let's just. Chlorine is greenish yellow. I have seen bromine myself, it is a violent red. And if we talk about iodine, it is a violet color. Like I don't know if you can see this, but basically it's like this color. Okay. So that was it for the physical properties. We can now talk about the chemical properties of group 17 elements. How much time? Yeah, 20 minutes. So what are the chemical properties of group 17 elements? Basically, so first let's talk about the oxidation states. Wait, let me arrange my color palette again. Yeah. So what oxidation states can we expect from the group 17 elements? Basically, fluorine always shows an oxidation state of -1. I don't think there's any exceptions to this. Like fluorine is the most electronegative element, so nobody, the rest of the 117 elements, they cannot displace fluorine's wish to be -1 oxidation state. So, but the rest of the halogens are easier to manipulate. That sounds similar. Leave it. So, the rest of the halogens are easier to manipulate and they can also show -1, but by unpairing their electrons, they can show +1, +3, +5, and even +7. So just see how much manipulation can cause you to bend your own limits. This was not about halogens, but let's not dive into that topic. This channel is not for that. So another point is that fluorine is the strongest oxidizing agent in group 17, and it can oxidize other halide ions in solution phase. What does this mean? That if you put fluorine ion with a halide ion of any other element, be it chlorine, be it bromine, chloride ion, bromide ion, or iodide ion, this can oxidize this ion into its own diatomic molecule plus two fluoride ions. How is this an oxidation reaction? Because Mandabuddhi, this was in -1 oxidation state and suddenly it is in 0 oxidation state. So this is a good oxidizing agent because it just oxidized it. And the other halogens have oxidizing property as well, that their oxidizing ability basically decreases as we go from top to bottom. What does this mean? That fluorine can oxidize bromine, bromine can oxidize iodine, and so on. And last thing I want to mention about this is that fluorine is such a strong oxidizing agent that it can even oxidize water itself. Like this guy just oxidizes water to oxygen and H plus ions, and it gets reduced itself to fluoride ions. But do you look at the magnitude of that power? Like it's removing the oxygen from water itself. What? Like this even shocked me at first, but I guess yeah, some elements can just do that like it's a daily thing for them. But yeah, enough yapping about that. I hope you know that the anomalous behavior of fluorine is again due to its small size, high electronegativity, and non-availability of d orbitals in its subshell, and also its low bond dissociation energy. Now that was it about chemical properties. Let's learn about their chemical reactivity. What chemical reactions can we explain from the group 17 elements? And the NCERT tells you the reactivity about their reactions with hydrogen, oxygen, and metals. And it also mentions some extra physical properties which you have to remember. I am sorry. But yeah, it won't be that much of a pain to remember. So just bear with me, and this can increase your score by 10 to 12 marks. So let's begin with hydrogen. How do the group 17 elements react with hydrogen? Basically, the reaction is quite simple. They react with hydrogen to give their hydrogen halides. Compounds like HCl, HBr, HI, and so on. Now, what were the extra properties I was mentioning? You have to remember that their acidity decreases bottom to top. What does this mean? This means that hydrogen iodide is more acidic than hydrogen bromide, greater than hydrogen chloride, greater than hydrogen fluoride. And just for the fact, let me tell you that all of these are toxic to you. And hydrogen fluoride is toxic for a completely different reason, which we will not discuss. But maybe I just thought of letting you know that they're all toxic. And again, following the basic funda that if a compound is more acidic or basic, that means it has higher tendency to change its current state of existence, which is why their stability, like I'll mention this is acidic strength, but their stability increases in the opposite order, which means that hydrogen fluoride is more stable than hydrogen chloride, and it is more stable than hydrogen iodide. So this is the order of stability. So I guess that was it about the hydrogen part. Now let's learn about oxygen's reactions with the group 17 elements. What reactions can we expect with oxygen here? First of all, we also learned this in group 16 that there is an oxide which exists, which is OF2. And in fact, let me tell you that O2F2 also exists, but only OF2 is stable at room temperature. And this is one of the very rare cases in which oxygen is forced to bear a oxidation state which is not -2, and here it bears an oxidation state of +2. And in O2F2, this is a peroxy linkage and it bears an oxidation state of +1. And these are the two oxides of fluorine which exist. Now let's move on. And for group 17 elements, most oxides are unstable. Like most of the group 17 element oxides are unstable. Most of them. Now, while I don't think this is important, but since the NCERT mentions you should learn it, that O2, F2 and OF2, they are both strong fluorinating agents, which means they are good at adding fluorine to compounds. And in fact, O2F2 oxidizes plutonium to PuF6, plutonium hexafluoride, and this reaction is used to remove plutonium from basically nuclear wastelands. You know, plutonium is used in nuclear stuff, and once it's done being used, we can use O2F2 to remove it from the basically the battleground or whatever the test site. And that was it about OF2 and O2F2. Now, as a general trend, the oxides are stable when we move from top to bottom, which means that oxide stability decreases in the order, iodine oxides being most stable, followed by bromine oxides, and followed by chlorine oxides. And this will be illustrated by the next example, where I will tell you about the oxides of chlorine, which we expect to be less stable, and they are exactly less stable as we expect, because chlorine oxides like Cl2O, ClO2, Cl2O6 and Cl2O7, they tend to explode. Yeah, which is why these are unstable. Also, I am very sorry, I made a small mistake in this part. Actually, the order is that is bromine oxides are less stable than that of chlorine. I mean, I didn't read properly, and in fact, even in my notes which are in front of me, it is written wrongly. So I am very, very, very sorry for that. So let's continue now. That bromine oxides like Br2O, Bro2, and bro 3 are least stable oxides, are least stable of the group 17 oxides, least stable halogen oxides. And I did not mention halogen here. The chlorine oxides basically they explode. Like I forgot to mention this in the written part because some of you will be taking this PDF from me. And basically the iodine oxides, they are insoluble solids and they can decompose on heating. And basically I2O5 is a very good oxidizing agent and is used in estimation of carbon monoxide. Like they can ask this as an MCQ, and I want you to remember that they are used to estimate the basically carbon monoxide. Must be some titration shit, I don't know. But yeah, that was it about their oxides. And now we can move on to one of the final parts of this chapter, which is their reactions with metals. Now they react with metals to form their metal halides. An example of this reaction I am going to give you, which is basically magnesium plus bromine gives MgBr2, magnesium bromide. So basically this was the metal, this was the halogen, and this was the metal halide. Metal halide basically वही metal के साथ halide, and the the halides in higher oxidation, I just threw my pen, the halides of metals in higher oxidation state are more covalent than the ones in lower oxidation state. And this should be quite obvious to you because as we know via Fajan's rules that if we have an anion and a cation, if the cation pulls this electron cloud, this more the pulling effect is there, this bond gets increased in covalent character. And this phenomena is directly proportional to charge on the cation, and charge is directly proportional to oxidation state. So higher oxidation state would imply that this charge is greater and it is able to pull all of this cloud towards itself, and hence this is more covalent. For example, SnCl4, PbCl4, SbCl5, and uranium hexafluoride are more covalent than SnCl2. My handwriting is terrible. SnCl2, PbCl2, SbCl2, you get the point, right? And what was the last part? Their reactions with other halogens. How do the group 17 elements react with themselves? Basically, they combine amongst themselves to form compounds called interhalogens. How do the interhalogens look like? Compounds like basically, say, BRF5. You must have studied in chemical bonding. BRF5, IF7, ICL, and I guess that was it. Only last thing I wanted to say that in compounds like this, the smaller one will be more in number, and the bigger one will be the central atom. Like similar, you can see here, central atom. This is the smaller number, and I think that was it for the group 17 elements. So let me know if this lecture helped you, and I have kept the NCERT right in front of me during the entire lecture, which also explains why there are so many pauses in between, because I'm cross checking every second to see whether what I'm telling is right. And if you remember, I also made a mistake around here where I first told you that this order was incorrect, and I humbly apologize for that, but I'm not going to record the entire thing again just for this one minor mistake. So that was it. And I thank you for watching my series up till this point. The final lecture of this series will be uploaded tomorrow or the day after tomorrow, in which we will cover the group 18 elements. And until then, thank you for watching this series so far, and thank you for all the love and support you have been giving to me. It really means a lot, and seeing my subscribers go up by like 100 in just 2 3 days, it means a lot to me, and it kind of makes me feel loved. And just keep sending love. I It means a lot to me. I think it is. I Guys, I think he's trying to say this means a lot to him. Yeah, I am. And also one announcement. If you are watching this till the very end, I want to ask you one question. After this P block series is over, do you want me to upload D block elements, or you want me to upload salt analysis? Let me know in the comments, and thank you for watching.